Hi guys, welcome to PyMath. In today's video, we're going to be covering some logarithm basics, and we're also going to be going over a problem. And the problem is that if log 5 to the base 10 over x minus y equals to log 7 to the base 10 over y minus z equals log 9 to the base 10 over z minus x, then calculate 5x plus y, x5 to the power of x plus y, plus 7 to the power of y plus z, plus 9 to the power of z plus x. Let's get started. Before we get started, let's revise the basics. So first we're going to revise the basics of logarithmic notation. We all know exponent notation, and we're just going to take this random example of a to the power of x equals n. For this example, logarithmic notation would be log n to the base a equals x. Okay, so you have to remember the conversion between exponent notation to logarithmic notation to solve this problem. And also we're going to be going over some exponents basics. So we all should know that x to the power of m all to the power of n equals x to the power of m multiplied by n. And similarly, x to the power of m multiplied by x to the power of n equals to x to the power of m plus n. Okay, now let's move on to the actual problem. So this is just the problem. This is just the equation given to us. It's just that, but we've added a constant here. And the reason we've assigned this constant is that we're working with ratios. We want to put this all into ratios. So that's why we've assigned this constant. Okay? So if we just take this part equals to alpha, the constant, and this part equals to alpha, and this part equals to alpha, and move the denominators up, we get log 5 to the base 10 equals alpha times x minus y. And similarly, if we do it for this, we get log 7 to the base 10 equals alpha times y minus z. And similarly, if we do it for this one, we get log 9 to the base 10 equals alpha z minus x. And now what we're going to do is we're going to express this, which is in exponent form, this, which is in logarithmic form, into exponent form. And the reason we're doing this is that the thing that we're trying to calculate is already in exponent form, but we're given our equation or expression in logarithmic form. So at some point in the process, we have to convert from logarithmic form to exponent form, and this is basically what we're doing now. So when we convert to exponent form, we get 10 to the power of alpha x minus y equals 5 for this one, 10 to the power of alpha y minus z equals 7 for this one, and 10 to the power of alpha z minus x equals 9 for this one. And now what we're doing is we are putting both sides to the exponent of x plus y. Or we're putting both sides to the conjugate of this value. For this specific example, it's x plus y. So we do 5 to the power of x plus y equals to 10 to the power of alpha times x minus y all to the power of x plus y. But for this example, the conjugate of this value is not x plus y, it's y plus z. So we put both sides to the power of y plus z. So that would be 7 to the power of y plus z equals 10 to the power of alpha times y minus z all to the power of y plus z. Similarly, the conjugate of this is neither y plus z or x plus y. It's z plus x. So we put both sides to the power of z plus x. So that would give us 9 to the power of z plus x equals 10 to the power of alpha z minus x all to the power of z plus x. And What we're doing now is just we're simplifying this expression and this expression and this expression. So for this expression, we get 10 to the power of alpha x minus y x plus y because you multiply these two terms, and that would give us 10 to the power of alpha x squared minus y squared. Similarly, this would give us 10 to the power of alpha y squared minus z squared because if you really think about it, it's alpha multiplied by a difference of squares expression. So all you have to do is difference of squares identity. And similarly, it's alpha multiplied by z squared minus x squared. Just difference of squares, guys. Okay, so now we have all three of the terms we need here. 5 to the power of x plus y, 7 to the power of y plus z, and 9 to the power of z plus x. So when we multiply all these three, which are equivalents, we get 10 to the power of alpha x squared minus y squared, multiplied by 10 to the power of alpha y squared minus z squared, multiplied by 10 to the power of alpha z squared minus x squared. And since they all have the same base, which is 10, you can add these all together. And when you do that, you get 10 to the power of alpha x squared minus y squared plus y squared minus z squared plus z squared minus x squared. Because alpha is really just a common term between these three, so you can factor it out. And when you simplify all the x squares cancel out, all the y squares cancel out, and all the z squares cancel out. So that just gives us 10 to the power of alpha times 0, which is equal to 10 to the power of 0, which is equal to 1. Thus, 5 to the power of x plus y times 7 to the power of y plus z times 9 to the power of z plus x equals to 1. Thank you guys for watching. If you enjoyed, please subscribe, and I'll see you next time.